Now if we look at example 6, we want to determine any asymptotes and intercepts for f of x equals 2x cubed plus x all over my polynomial. I want to graph the function and state its domain. Okay, let's start with the domain. I know the domain happens when my denominator equals 0. So x squared plus x minus 12, well, that'll be x plus 4 and x minus 3, right? So I'm going to have a vertical asymptote at -4 and a vertical asymptote at +3. So my domain is going to go from -infinity to -4. And then from -4 to +3. And then from 3 to infinity. So we answered our domain question right away. So I'm going to go to the left 4. 1, 2, 3, 4. I'm going to make a vertical line going through 4. And make a horizontal line going through 3. And notice since my degree is greater, I have to use long division to find out my slant asymptote. So I'm going to say 2x cubed, which would be plus 0x squared plus 0x plus 0 divided by x squared plus x minus 12. Well, x times what gives me 2x cubed? Well, that would be 2x, wouldn't it? So I go 2x. So 2x times x squared is 2x cubed plus 2x squared minus 24x. Change all my signs. So then I get 2x squared plus 24x plus 0. So then I'll go a plus 2 there, won't I? So I'll get 2x squared plus 2x minus 24. And then I get a remainder. But remember, remainder doesn't matter. So I'm going to, my remainder doesn't matter because as I approach infinity, it's going to go towards 0. So I'm just going to graph 2x plus 2. And there's my oblique asymptote. I don't know why it didn't have that. I'm going to redo that. It looks kind of ugly. I didn't draw that one right there. So okay, now let's look for our intercepts. So my y-intercept is when x equals 0. So I'm going to get 0 over 0 plus 0 minus 12. So 0 divided by -12 is going to be 0. So my y-intercept is at 0. Notice that's also my x-intercept, isn't it? So I've got both my x-intercepts. And then we'll do is we'll make a table to figure out how that approaches our vertical asymptotes. And I know I've got one of my positive asymptotes at 3, so I'm going to go to the right of 3, which is 4, to the left of 3, which would be 2. And I'm going to find those values. So now if I go to the right of 3, if I go 2 times 4 cubed, that'd be 64 times 2 would be 128. All over. If I go 4 squared, which is going to be 16 plus 4 minus 12. and that will give me 8. So if I go, I get a nice big number, don't I? So 4 is going to be kind of high. So what's happened here is my graph is going, whoa, got to see this. My graph is going to look like that at that point. And then let's go to the left of 4. So let's go 2. So 2 squared, or 2 cubed is 8, times 2 is 16. All over we put in 2. 2 squared is 4, plus 2 is 6, minus 12 is negative 6. So 16 over negative 6 is going to be a negative then, isn't it? So it's going to be down here someplace. And then I would do the same thing for negative 3 and negative 5. But once I see how my graph, the pattern of my graph, I know it looks like that. And then where my asymptote is, it's going to go on the other side, like that. And there we have it. And let's check that. I don't think I've graphed this one yet, so we're going to have to do it together. So I'm going to graph y equals, I don't care what function you use, y equals, I'm going to go 2x cubed, divided by, and then I have 3 terms in my denominator, so I'm going to put parentheses just to make sure, x squared plus x minus 12. And I can see, here's my, might have to expand my graph out so I can see my other one, but I can see my oblique asymptotes there, and I can see my vertical asymptotes. So I can type in like x equals 4, so I can see that. Whoops, not x equals x, x equals 4. And then x equals negative 3. And y equals 2x plus 2, so I can see those asymptotes. There, you can see where they are.